Hi all. So in the last session we discussed about OOPS concept. So where we basically covered upon data hiding, encapsulation and tightly encapsulated class. So in this session we'll move further with the most important topic being asked, that is inheritance. Also we'll discuss about composition and aggregation, and we'll learn few things about what method signatures are. So let's quickly refer to our doc that we are having here. So in the last session we discussed what is tightly. We know that tightly encapsulated class is a class that has each and every variable declared as private. So we discussed few examples around this. Now we'll be moving to the next topic, that is a relationship. So is a relationship is nothing but, it is also known as inheritance, is also known as is a relationship. So it can be achieved using the extends keyword. So be sure that extends, it's not extend, it extends keyword. So main advantage of inheritance is that we use code reuse, it is used for code reusability. Okay, so we'll see in the further examples what how code reusability is there, how we can achieve the code reusability. So let's move, let's see an example practical. So we have a class P that is a parent class. Inside that class we have a m1 method that has a statement of system.out.println parent. And we have a class C that extends P, that has a method public void m2 and there is a statement as a println statement saying child. Okay, so this is the parent class, this is the child class that is extending this parent. Okay, so we'll see few of the conclusions around what parent child chaining here means. Okay, so let's see in, let's create, let we have a class test that we have created. We have this main method. So first we are, what we are doing, we are creating object of the parent class, so that is parent P is equal to new parent. So by using that parent we are calling p dot m1 and p dot m2. So what is valid here, what is the valid case here and what is the invalid case, we will see this. Okay, when we are using p dot m1, so what we are doing here, so we are calling the m1 method that is present in the parent class. So that is quite valid, that it's inside the parent class, and by using the parent object parent reference we can call that method. Okay, but when we are calling p dot m2, so m2 is not present inside the parent class, m2 is present inside child class. So that is that cannot be called. Okay, so why? Because by using parent reference we can only call parent specific methods, but by using parent reference we cannot call child class methods. Okay, so since how, let's see a practical example, let's see let's understand. Class parent, whatever properties parent has is by default available to the child, but whatever properties whatever properties child has by default not available to the parent. Simple as that. In real time, whatever properties our parent hold, so that is hierarchized into R. Okay, and we get those properties, like we get let's say the hairstyle, or we can say the color, or whatever in real life we say that, or whatever the face look or face cut we have that resembles our parent or ancestor or something. Correct. So but our parent does not have our properties. Correct. So we have inherited from them, not they have, they won't be able to inherit our properties. Okay, so they have inherited from their parent and we are inheriting from our parent. So that is what the logic here inheritance means. Okay, you inherit the property of a parent. Okay, and so you can also define, you will have your own properties as well, but you will have your parents properties by default available to you as well. That is what here it means, that parent reference can be used to hold parent object, and by using that parent reference we can only call parent specific methods, we cannot call child specific methods. So if we run this, so p dot m2 will give a compilation error saying that cannot find symbol, which symbol method m2 and which location class P. That it is saying that it cannot find the m2 method in class P since this is not present there. Okay, so since this is a child method, so we cannot call that. So okay, so then comes the next conclusion, that C is equal to new C. So child reference and child object. So by using this reference we can call what, we can call both the methods available in the parent. Since we are inheriting from the parent, we are using extends keyword and inheriting those method. So by default they will be available to us. So c dot m1 is also valid here, and c dot m2 is also valid because it's a method inside the child class itself. So both of these, a child can call parent method as well as his own methods as well. Okay, so this is for this is about child reference. Okay, then parent reference and child object. Okay, so parent reference and runtime object is child. So p dot m1 is valid because this is a method inside parent class, but p dot m2 is still not valid because why? We can use parent reference to hold child object, but if whenever there is a story, whenever something comes around parent, you can only call parent specific methods by using that object reference. You cannot call anything related to child. So again, it will give you a compilation error saying that cannot find symbol method m2 location class p. Okay. Oh, okay. So this is also it's a just in short term we can say by using parent reference we can only and only call parent specific methods. We cannot call anything related to child. Simple as that. Okay. So now next point where what it is that c1 is equal to new p. This is an invalid case. Why? This will give an incompatible type error. Why? Because parent reference can be used to hold child object, but child reference cannot be used to hold parent object. Okay, so in real time your parent only gives you your parents give you help you in making the decision, but you don't generally give may help in parents in making a decision. Correct? They only correct you, you don't correct them. You can relate with this that by using child reference you cannot hold a parent object, but by using parent reference can be used to hold child object, but child object cannot be used to hold parent object. Okay, since it is a parent, so that is why it will show incompatible types found p required c. Correct? So let's see. Okay, it's written here as well. Whenever parent when whatever methods parents has by default available to the child, and hence on child reference we can call both child parent and child class methods. We are talking about this that by using parent reference, uh, parent methods are by default available to the child, and by using child reference we can call both methods. Okay, so we can call both of them. Then it's written that then we have a point, whatever method child has by default not available to the parent, and hence on the parent reference we can't call child specific methods. Okay, so this is related to this that whatever method child has by default not available to the parent, so hence by using child reference, sorry, parent reference, we can only call parent specific method, we can't call child specific methods. That is what I explained you. So in the next point, parent reference can be used to hold child object, but by using that reference we can't call child specific methods. Okay, but we can call the methods present in the parent class. Okay, so parent reference can be used to hold a child object, but by when anyways by using that reference we cannot. I told you we cannot call sorry, child specific methods. Okay, so this is what this third point says to here, concludes to here, and then as simple, parent reference can be used to hold child object, but child reference cannot be used to hold parent object. That is invalid case. Okay, so let's move on further. So we know inheritance is a property where we inherit the properties of a parent class. What if in the case there is we did not use, there was no concept of inheritance? So let's see a clear example here. So we have class vehicle loan, we have class home loan, we have class parent personal loan. So this has 300 methods, this has 300 methods, and this has 300 methods. So out of these 300 methods there will be some set of property that a loan is that loan will be common to each and every loans. Correct? We have interest would be different, but there will be certain some criteria that each of the loans should follow that criteria, and then we have the different interest rates and everything and all. Okay, so let's say and there are 250 common methods here, 250 here, 250 here. So what we are doing without inheritance, we will have to write so much of code that is that it will increase the length of the code basically. So 250 common methods will be written in this file and this file, and then let's say we'll have to run all these files. So this will take so much this will be so much memory consuming and time consuming as well. So with reference to inheritance, how do we handle this? That we'll have a class loan that will that will have only 250 methods that are common methods, and then subcategorizing sorry categorizing the field, what we'll do, we'll have vehicle loan, we'll have home loan, we'll have parent loan, and what we'll do, we'll extend the main class loan that will have 250 methods, common methods, and we'll write our specific methods inside the vehicle loan. So vehicle loan will have only 50 specific methods, so we'll have to write only 50 more methods here in each class. We don't have to write those 250 methods as well. So that is why inheritance is so much useful for us, that this is how it reduces the code. This is the advantage basically, that says that we have the property of code reusability, we can say. We have, so the code is reusable like this. This is the example for that, you can give it in the interviews. So next comes the note that most of the common type of methods which are applicable for any type of child, we'll have to define in the parent, that I showed you. Most of the common methods that are available in any type of the child are defined in parent, and the specific methods which are applicable to the particular child will have to define in the particular child class itself. So specific methods, whatever there are there, we'll have to specify. Vehicle will have its specific methods, home loan will have its specific method, and personal loan will have its specific methods. Okay, so total Java API is implemented in the based on the inheritance concept only. So most of the common methods which are applicable for any Java object are defined in the inside the object class. That is why we say that object acts as a root class. Okay, so any class that inherits any class or not, but it is indirectly or directly the child of of the object class. So that is what it's written here if you read it. Okay, so then we have throwable in exception handling. Throwable acts as the root class, and in that also we have the common methods that are available to every exception or error classes that are available inside the throwable method as well. We'll see in the exception handling section. So that is what was about inheritance, and then we'll see what is multiple inheritance. A Java class can't extend more than one class at a time. Hence Java won't provide support for multiple inheritance in classes. So in Java we can extend one class at a time. That is, A will extend B and then B will extend C. We cannot write class A extends B comma C. So this is totally invalid. Okay, now if our class does not extend any other class, then only our class is the direct child of class object. So I told you that whether our class is extending or not, our class is directly or indirectly the child class of object class. So this is case is valid when uh, when our class is not extending any of the class. Okay, then it is known as the direct child of object class. But if it's extending any of the class, then it will be known as indirect child. So we can see in this example, if our class extends any other class, then our class is indirect child of object. Okay, so there is a concept. So you might say that this is also multiple inheritance, since object it is extending A and sorry, class A is extending B and object also. No, we have a concept of multi-level inheritance, not multiple inheritance. That A extends B, and B since B does not have any of the parent class, so B is directly the child of object class. So this is how it looks like, that A extends B and B extends object class. Okay, so there's a note also written here, either directly or indirectly Java won't provide support for multiple inheritance with respect to classes. Okay, why why we don't provide multiple inheritance? There's a reason of the we'll face a ambiguity issue in the sense, let's say there's a class. Let's say, yeah, in this example, let's say there are, this is parent 1, this is parent 2, this has m1 method, this has m1 method as well. So there's a class child C that is extending p1 also and p2 also. Let's say I called c dot m1, so the compiler will confuse to which m1 are you referring to. Correct. If, it will confuse, that it will say that do you want to reference the m1 inside p1 or inside p2. So it will confuse, and it will throw an compile time error. Okay, so this is what the ambiguity problem is. This is the most important question asked in the interview, that why Java does not provide multiple inheritance. So you can say, if we extend two class and both the classes have the same method, and once inside the child class we try to call the same method, so the compiler will confuse that which of the method are you referring to from which class. So it will show a compile time error. Okay, So the next thing is Java provides multiple inheritance with respect to interfaces. So we can extend multiple, an interface can extend any number of interfaces. Okay, let's say interface A, interface B, and interface C. Because why? Because interface, inside interface methods do not have any implementation. That is why you can extend any number of interfaces. That is what, yeah, that is what here is, it's explained that in inside interface we don't have any implementation, so the child interface can extend any number of interfaces. Okay, that's written here as well. Even though multiple method declarations are available, but implementation is unique. Therefore, there's no chance of ambiguity, since while extending an let's say a class is implementing an interface, so it will provide the unique implementation for that interface, correct? So that is why every class extending will provide an unique implementation to that interface, to that method inside interface. So we'll study this in the interface section. So this is the gist around this was that any class cannot extend multiple classes. Okay, multiple inheritance is not possible due to ambiguity issue. And the ambiguity issue, I told you that there are two parent classes and they have the same method. If they have the same method, then there will be an ambiguity issue with the compiler, that it won't be able to recognize which method you are trying to call, that is either of the classes, that is of the parent 1 or parent 2. That is what, this is the most important question that will be asked in the interviews. So let's see cycling inheritance. Cycling inheritance is something like A extends B and B extends C and C extends A. So this is not possible in Java. Very straightforward. This is not possible. Or if someone asks you, then you can say there is it is not possible. Okay. So next we come on to has a relationship. Has a relationship is what is known as composition or aggregation. So has a relationship is nothing but composition or aggregation. So there is no specific keyword for has a relationship. If you want to implement the partial functionality, you can go with has a relationship. If you want to implement a fully functionality of the parent class, you can go with inheritance by extending. Okay, so just simply if you are creating an object of another class, that is nothing but has a relationship that can be set to as. So there is no specific method to implement has a relationship, but most of the times we are depending on new keyword. That is how we create an object. That is simple. So the main advantage of has a relationship is also reusability of the code. Let's see, there's a class engine, there's a class car. So by using the engine object, we'll be able to call the engine class functionality. This is nothing but has a relationship. So in has a relationship we come upon two things, that is composition and aggregation. So let's see what is that. So in composition, what we do, so we say that with, let's say, without existing container object, if there is no chance of existing contained object, then container and contained object are strongly associated, and this strong association is nothing but composition. Okay, let me explain you that without existing the container object, if the container object cannot exist, then inside that the contained object also cannot exist. Then there's a strong association between the container and the contained object. Let's see the example, that without existing university there will be no chance of existing departments. Since if there is no university, how can a department exist? Correct, that is nothing but composition. There's a strong association between university and department. That is what it says. University consists of several departments. Without existing university, there is no chance of existing department. Hence, university and department are strongly associated, and this strong association is nothing but composition. Okay, so this is explained that this is the container object, that is university, and this is the contained object, that is the department. So we have a strong relationship. If university does not exist, the departments cannot even exist. We haven't heard there's a something, a school or something of a department, correct? We have a university, and inside a university we have departments. Okay, so now comes aggregation. So aggregation is just the reverse, that without existing container object, if there is a chance of existing contained object, then there's the container and the contained object are weakly associated with each other, and this weak association is nothing but aggregation. The simple example, we can say that without existing these professors, there is a chance of existing these departments, correct? Department consists of professors, several professors. Without existing department, there may be a chance of existing professor object. Hence department and professor are weakly associated with each other, and this weak association is nothing but aggregation. Without existing this department, there's a chance that the professor will never go off, correct? He can work on some other university's department or some others another university's department, let's say. So without existing this, there's a chance of existing these as well, correct? So that is what aggregation means. Although this is not mostly asked in the intros, but you should have the concept if someone says. Okay, so in composition, strong objects are strongly associated, while in aggregation, our objects are weakly associated. That is what we read about. So in composition, the container object directly contains the object. Yeah, you can say that university directly binds up these contained object and inside. Whereas in aggregation, object holds just the reference of that. So we can say professor holds just the reference with this department. If this department goes, then he can work on, he'll have some other university in that way. He can work on some other department as well. Okay, so that is what aggregation and composition means. So what is a versus has a? I told you that if you want to implement the total functionality, you can go with what is a relationship that is nothing but inheritance. If you want part of the functionality, you can just create an object of that class and just use that specific method as well. So that is what has a relationship means. Okay, so next comes the topic is method signature. So what is method signature? In Java, method signature consists of method names followed by argument types. Okay, so what does that mean? So let's say there's a method public static int m1, and these are the argument types. Okay, so what is this? Access modifier, then this is static in nature, and then this is the return type, and this is the name, and this is the argument types. Okay, so what did we read? Method signature consists of method names followed by the argument types. So method name and followed by the argument types int and float. So this is what a method signature of this method. Okay, so return, next point is that return type has no role play in the method signature. Return type is not a part of method signature in Java. Okay, so compiler uses this method signatures to resolve method calls. Okay, let's see with an example. Let's say we have a class test public void m1 int I that accepts integer argument. Okay, then we have another method public void m2 string s that accepts string as an argument. Okay, so let's create an object. So we are creating an object test t is equal to new test, and we'll call t dot m1 of 10. So what this, which method this will invoke? This will invoke this one, that is m1 of 10. Correct, m1 of int I. So inside the call stack, we'll have something method signature as that m1 int. This will resemble, this is the method signature of this is the method signature of this method. M2 string, this is the method signature of this. So inside the call stack, we'll have something method table like this. Okay, so now I'll call m2 of Durga, so string. So what is this? This will resemble to, this will pass, and this will, because we have a method signature matching to m2 of string, so this is also a valid statement. Then t dot m3 of double 10.5. So why this is invalid? Since there is no method signature m3 of double in the call stack, in the method table of the calls. Okay, so this will give you a compile time error saying that cannot find symbol method m3 double location class test. It is specifying the basically the method signature cannot find that. Okay, method and the method signature it is showing. So that is what there is a role play of method signature in the compilation time, correct, while resolving the methods. So let's see, compiler uses method signature while resolving method calls within a class. Okay, the next point is within a class, two methods of the same signature are not allowed. Let's say we have public void m1 int I, we have this one public int m1 int x. So what is the change here? We have changed the return types, that this will return void and this will return integer type value. Okay, and we are returning 10. Now if we call test t1 is equal to test t is equal to new test and t dot m1 of 10, so there will be ambiguity, correct? So since the it will it will say that inside method signature, we I told you that we do not reference to the return types. So there will be a method signature, only one method signature will be made there, that will be m1 and int. Okay, when the compiler will try to make this method signature, this will also be m1 int, since there is no role play of the return type. So this will throw an compile term error saying m1 int is already defined in test for this. Okay, That is what method signature was. So in the next lecture we'll study about overloading. So let's meet in the next lecture. So up till then, I hope the session was quite informative, and thanks all for watching this. Thank you all.